Okay, in this video lecture we're going to talk about the System International and how it relates to the metric system and some different prefixes that we're going to be using throughout the year. So System International is really just an updated version of the actual metric system. They just went in and kind of cleaned it up a little bit and standardized a few things even within that system. Now the System International, or we usually abbreviate it the SI system. The SI system really is a useful tool for us because the way they've set it up makes it much easier to work within different units and convert between different units. Some of the nice things about the SI system, it is universal. So the scientific community has adopted this unanimously and use it universally throughout any country in the world. The base 10 factor of being the SI system is really its backbone. So everything is off of base 10, meaning that everything's a factor of 10. So converting in and out and shifting units is very easy and very quick within this system. And then finally, which sometimes people forget about, that the prefixes are the same for every unit. So for example, if you have centimeters in your system for meters, if you have centigrams, the centi means the same thing. So a centimeter to a centigram or a centiliter means the exact same thing. So once you learn the prefix that centi means 1/100th, you now know that that prefix will hold true in any of your measuring things that you see. You can even have like centiseconds, for example, or milliseconds in terms of 1/1000th of a second. So having that prefix is really kind of a useful thing for us to have. Much different and much better than what we kind of experience here in the United States with the imperial system, where you have to have 3 feet to a yard and 12 inches to a foot and 5,280 feet to a mile, and there's 16 of some ounces to a pound and 8 ounces to a pint and pints to quarts and quarts to gallons. It's all different, so there's so much more to memorize and learn. We just have grown up with it, so we kind of have it in our heads and memories. But within the SI system, it's much simpler and actually more clean to work with. Now, within this system, you have your standard base units. So these base units are single, simple measurements that you can make. Things like the meter, which is a certain length, the kilogram, which is a mass, seconds is our time, and so forth. What you see highlighted on the screen in blue, those are the primary ones that we're going to use this year in honors chemistry. So if you notice, we have something called the amount of a substance. That's the mole. Now the amount of a substance, or this mole, is a unit we'll get much more familiar with throughout the year. But for now, all I need to realize is that we are going to be dealing with amounts, and the way you measure amounts in terms of atoms and molecules and compounds is something called the mole. So that's kind of all you need for now. Temperatures in kelvins, and we'll talk about the Kelvin scale in a different video lecture for you guys. Time is in seconds, so we really don't ever work with minutes or hours or days here. If we use a lot of seconds, we use kiloseconds or megaseconds or gigaseconds. So the unit is actually the second. And then finally the mass is in kilograms. Now you might be kind of intrigued to see, well, why is the base unit the kilogram and not just the gram? Well, if you think about it, a gram is a really small amount of mass. There's 454 or so grams in 1 pound. So it's really tiny. Now because it's so small, it isn't necessarily very useful in a lot of macroscopic applications. So for example, if you're doing business conference or trade or industry, using grams would generate gigantic numbers. So what we do is we use the kilogram as our basis instead, and that way when we're working we can use numbers that aren't so big. Now if you take these base units and if you start to calculate new things from that, we can get derived units. So for example, density is a derived unit because density is a thing that comes from mass, which is the kilogram, divided by meters, which is our lengths, cubed. So that would be your mass over volume. Even volume itself is actually a derived unit because we cube the length to get us cubic meters. Now within these derived units, I'm not going to expect you guys to memorize these right now, but these are the ones that I'm highlighting are the ones that you will be learning or working with throughout the year. So density, energy, frequency, pressure, velocity, volume, all those are different units that we will be working with, and we work in those derivations throughout the year. However, these base units, for this particular unit, you are required to kind of memorize these and be able to talk about why kilogram is there instead of grams and what a Kelvin is and so forth for those. All right. If we move on to the prefixes part of this segment, we'll notice that here's a list of the prefixes you need to know within the SI system. It is not all the prefixes. Actually, if we jump out and we go to our unit page, you'll notice that I have the SI system full prefix list here if you're interested in seeing it. So this is all the prefixes that we utilize in the whole system. I do not expect you to know all of these or work with all of these, but for the most part, this is everything we have so far. So we have everything as high as a iota down to a yocto in terms of our different prefixes. So, and they all have their symbol in them. You'll notice that most of the ones that are bigger than your root, the gram, meter, liter, second, most of them besides hecto and kilo are actually capitalized. So capitalization really helps with that because we do have the D for deca and then the little d for deci. And we have the capital M for mega and we have the little m for milli and so forth. So you'll see that some of these are actually capitalized so you can distinguish between the two. But this is a full list of ones we have. But again, I'm not expecting you to know the full list, just want you guys to see it. The actual list that we're working off of is this one. So you should know what giga is: mega, kilo, deci, centi, milli, micro, nano, and pico. And of course your root or your base of all this stuff sits right between these two lines here. So this is the gram. Now when you look at this, what this kind of chart tells us is here's your symbols. Notice that micro is the Greek letter mu, spelled mu, and it looks kind of like an italicized U with a kickstand kind of sticking off of it. Besides that, you see the capitalized mega and giga up here. And if you look, if you have a kilogram, that means there's 1,000 grams in it. If you had a megagram, that means there's 1 million grams in it. If you have a gigagram, that's a billion grams in it, or billion meters in a gigameter. Now, once you get on the other side of this line and we get into small numbers, you notice how we'll have a lot of small ones because chemistry is a world of very small things. Deci, centi, and so forth. If you put the base unit with any of these numbers, the pattern still holds true. So for every 0.001 grams, you have 1 milligram. For every 0.00001 grams, you have a microgram. Now, another way of doing that is you could say that there's 1,000 milligrams per 1 gram, and you could look at it that way also. I really don't care how you do it in terms of your conversions, as long as you get the right conversion done properly. And then again, we also can do it by powers. You can kind of see the difference of powers here on the system. So you are responsible for these different prefixes and being able to convert in and out of those as we go through this unit, and you will be tested on that in our assessment. Okay? Now, that ends our segment on the SI system. If you need some additional help with that, please come see me in class or after class. Thank you.